Hello guys, good afternoon. You are welcome to the YouTube channel, the Explicit Tutorials, and my name is Dr. Joseph. In today's video, I shall be taking us in the 122 alimentary system, a subtopic called mechanism of digestive water enzyme. Now, in this video, we are going to be treating the various enzymes that speed up the rate of our digestive process. Now, the various enzymes are one, we have the carbohydrates. Now these carbohydrates, they act on glycosidic bond. As we progress, I shall be discussing more on carbohydrates too. We have the lipases. Lipases, they are fat and oil digestive enzyme. They act on what? Esters bond. You know the end product of fat and oil is what? Fatty acid and what? Glycerol. And number three is what? The proteases. No, proteases are protein digestive enzyme. Alright, they act on what? Peptide bond. Alright, they act on peptide bond, thereby converting protein to what? Amino acid. So these are the various enzymes that stimulate the rate of what? Digestion. But we are going to be treating each carefully. So let's start. Now, as I said before, I said lipase is what? Fats and oil digestive what? Enzyme. And the end product of fat and oil is what? Glycerol, fatty acid and glycerol. Now, fat is emulsified. It's emulsified. Fat is what? Emulsified in the bile, which is produced by what? The liver. Alright, which is produced. I told you also that the cholecystokinin, like CCK, stimulate the liver to produce what? Bile. So this bile helps in the emulsification of fat. And you know that fat is not water soluble. It cannot dissolve in what? Water. Now, most fatty acids, most fats that animal utilizes is from that of esters of fatty acid and higher glycerol, such as trihydroxy alcohol triglyceride. Most fats that animals utilize or they use to stimulate the process of what? Growth or digestion or development is from that of what? Fatty acid and what? Trihydroxy alcohol what? Triglyceride. The type of what? Esters. Now, fats is also termed a triglyceride. Fat is also termed what? A triglyceride. Alright, so please take note that another word for fat is also called is what? Triglyceride. Now the end product of triglyceride are fatty acid. That is the end product of what? Triglyceride are what? Fatty acid, glycerol, and monoglyceride. Which of the following are the end product of what? Triglyceride. They are fatty acid, glycerol, and what? Monoglyceride. Now, fat has two regions: the polar hydrophilic region and the non-polar hydrophobic region. Fat has two regions: the polar hydrophilic region and non-polar hydrophobic region. The word polar solvent is a solvent possessing two poles, negative pole and what? Positive pole and negative pole. A good example of that is what? Water. Now, the fat molecules in a polar solvents such as water, they'll not clump, they'll come together and form what is called what? Micelles, all right? Micelles are formed by the clumping or by the coming together of two or more fatty acid in what? Water, in two or more fats in water molecule. And this micelles has or have the ability to diffuse at different what rates. And so in micelles, the hydrophilic part is pointing towards the surface of the fats, but the hydrophobic region is pointing towards the middle of what? The fat. The part I want to take note of is not all this grammar we are speaking now. One, lipase work on what? Esters bond. Good. The end product of glyceride is what? 3. Fatty acid, glycerol, and what? Monoglyceride. Another name for fat is what? A triglyceride. And I said that most fats that animals utilize are from esters of fatty acid and what? Trihydroxyl alcohol, what? Triglyceride. So these are the things you should know on what? Lipids. Take note of that. Now the next one is what? Protease. Now I said that protease is what? Protein digestive enzyme. Hope everything I've said so far is understood. Now I said protease is what? Protein digestive enzyme. It is protein digestive enzyme, that is, it acts on peptide bond, converting protein to what? Amino acid. Now proteases. Now proteases are divided into two. We have endopeptidases and exopeptidases. We have endopeptidases and what? Exopeptidases. These are the two divisions of what? The proteases. Now, what is the function of these two idiots? The function of these two idiots are: one, the endopeptidases, all right, it acts on the peptide bond present in the protein molecule, thereby dividing it into different segments or sections. Proteases are divided into exopeptidases and what? Endopeptidases. The endopeptidases act on the peptide bond, thereby converting the protein peptide bond or protein substances into different segments or what? Section, which means that the endopeptidases increases the number of chains present in what? In the peptide bond. Now the work of the exopeptidase is to act on terminal peptide. Take note of that. Terminal peptide, thereby converting into what? Amino acid. Now, what the endopeptidases do is just to render the peptide bond vulnerable. They divide it into different sections, like split on it, work on it, then after which the exopeptidases are to complete the function or the reaction. What they do is just to act on this terminal peptide, thereby converting into what? Amino acid. Terminal peptide is to what? Exopeptidase or exopeptidases. Take note of that. Now, we now have the last one, which is called what? The carbohydrates. Now, carbohydrates, I said, are enzymes that act on the glycosidic bond present in carbohydrate molecules. Now, there are two types of carbohydrates. We have the polysaccharases and we have the glycosidases. These are the two enzymes that carbohydrates are divided into. Now, the function, the most commonly known polysaccharides, is what? Amylase. The most commonly known polysaccharides is what? The amylase. And the amylase converts carbohydrates into starch. That is, the polysaccharides, they convert large molecules of what? Polysaccharides. They convert large molecules of polysaccharides, such as starch in green plant and glycerol in what? Animal. Alright, I said polysaccharides or polysaccharides convert large molecules of polysaccharides, such as starch in plants, glycerol in animal, and on the other way they are converted into trisaccharide and mono. Okay, let me see if it will enter this place. So please, polysaccharides, they convert large molecules of what? Polysaccharide, such as starch in plant, glycerol in animal, to triglyceride or what? Diglycerol, to trisaccharide or disaccharide. So right. And that's making me to bite my tongue now. So again, so as soon as starch or glycerol are converted to these and other carbohydrates are converted to what? Monosaccharides. Through what? Hydrolysis. Hydrolysis is the opposite form of what? Condensation. I said that this trisaccharide, disaccharide, and other carbohydrates are converted into another trisaccharide or what? Monosaccharide, called raffinose in plants, and sucrose in what? Animals. All right, so these are examples of what? Trisaccharide. I see that this disaccharide or trisaccharide are converted into trisaccharide, such as raffinose in plants and sucrose in what? Animals. And this trisaccharide, on the other hand, is converted into what? Monosaccharide by the glycosidases. You see, it's a chain reaction. First thing first, the polysaccharides will convert large molecules of what? Polysaccharides will convert large molecules of polysaccharides, such as starch and glycerol in plants and animal respectively, into triglyceride and what? Glyceride. These two idiots will now combine with other carbohydrates to form a respective what? Trisaccharide, called raffinose in plants and sucrose in what? Animals. And these trisaccharides are converted into monosaccharide through hydrolysis to monosaccharide, alright, to monosaccharide by the glycosidases. So please, at this point, we call it a day. Don't forget to subscribe as you watch this video, and thanks for choosing my tutorial. Do have a wonderful day.